Hi and welcome! Every game needs buttons, so let's have a look at how to create and work with them. We start at how to create one from the hierarchy and how the component itself is structured. This will include understanding what the transition differences are and how to work with them. We will create a script and make the button call a method inside of it. We will then tackle how to assign a method through code instead of setting it up in the inspector. And before we start, if you want to ever be able to click and select one thing, and when you click another, your previous selection should be unselected, you are not looking for a button, but for a toggle. Buttons are sitting on a so-called canvas. That is the container for UI elements. I made a tutorial explaining the canvas in detail, but for this tutorial, we will just create a new one by right-clicking in the hierarchy and choosing Canvas. You can set these values as you like, but these work well in lots of use cases. They are handling how your UI will scale to the resolution of your player's monitor. There are two typical ways to create a button. The first one is right-clicking on the hierarchy, UI, Button Text Mesh Pro. Choosing this will create a basic button in your scene with a rounded-ish rectangle in gray with a thin outline and the word button on it. Checking it in the hierarchy, we can see this is consisting of two objects. One is the game object called button, which has the button component attached to it. Clicking on the small triangle expands the object and we see a Text Mesh Pro object that is parented to the button. You can easily rename the label of your button by changing the text inside of here. I have a whole playlist on Text Mesh Pro alone, so I won't go into much more detail here. Instead, let's go back to the main button. You can resize it by either entering values into the rect transforms width and height boxes, or clicking and dragging the blue bubbles or thin green outer lines of the button's corners. If you hold Shift while doing so, it will keep its aspect ratio. Holding Alt instead will scale opposite sides equally at the same time. In the image component, you can set how you want your basic button, that means a button that hasn't seen any interaction yet, will look like. Keeping Raycast Target toggled on is important, since you won't be able to interact with the button if you toggle this off. A second way to create buttons is to create an image first, and then attaching the button component in an extra step. That way, you won't get the added Text Mesh Pro label, but you can easily get that by adding a Text Mesh Pro child element if you need it. So, let's tackle the actual button next. We basically have four parts: checking for interactability, the transitioning method, navigation, and what's going to happen when the button is being clicked. Interactable is probably self-explaining, but why does your button go from solid color to halfway transparent? This has to do with the transition method. It always defaults to color tint, but there are actually four: none, tint, sprite swap, and animation. With color tint, you are expected to give it a reference to the target graphic that should be affected by the color transition. We will keep it at the default for now. Normal will change the base color of your button. It's why I would recommend to create a grayscale button to prototype your game with, as you can quickly change its visuals through this. Highlighted is the color it will transition to when the mouse is hovering over it. Pressed is the short moment when the button gets clicked by whatever means, and selected is the state of having been clicked until the player interacts with anything else. Disabled lastly is how the button should look like if the button's interactable state is set to false. That is why our button suddenly turned halfway transparent. Color multiplier specifies by how much this chosen color should be multiplied with the base color of your image. I actually never found a reason to pick anything but one. Fade duration handles how long fading from one color to the next will take. While longer durations might look nicely dramatic, the base 0.1 seconds is a nice and snappy transitioning time that works well in most scenarios. Especially when it comes to buttons, people click them and expect immediate results. Few will sit and marvel at long color transitions. Because we have a reference field for the target graphic, we do not need to have these transition effects affect the whole button. Let's add a new child element to our button by right-clicking on it, UI, Image. Now we can go back to the button component and drag that into the graphic we want to interact with. Sprite swap can give a lot more life to your buttons instead. Here, for example, I have a basic button I already created and want to use this as a base. It shouldn't change colors, as that would look quite hideous. I'll repurpose the extra image we added to our button instead. I have a range of guinea pig faces that should be displayed instead of changing the color. So I switch over to the decoration image and add the base version of my sequence of images. It will be the one the buttons will default back to when not interacted with. In the button component, I switch to Sprite Swap. Make sure I still have the correct image referenced and add the happy, wink and upset faces where they make the most sense. These changes will be instantaneous. Animation transitions are the mightiest of transitions, but they also need the most setup and knowledge about the animation system, which would honestly about double the length of this tutorial. If you want simple animations like this squash and stretch, I have a video on that which does not touch the animator. If you are sure you need the animator and watch a dedicated animator tutorial beforehand, make sure to name your triggers like the keywords in the animation transition block to make sure your animations get triggered at the correct time. Navigation is typically set to automatic and works all right out of the box. Duplicate your button and place it to the side. If you click on Visualize, you can see in which directions buttons should be highlighted when the player hits Tab, for example. This warrants its own tutorial, as it requires working with yet another component and needs a bit of setup to work depending on your input system. Let's tackle clicking behavior next. Every button comes with a Unity event box where you can set up what is supposed to happen and in which order when the button gets clicked. Let's write a short script for this. We have a script with two methods. If you want to assign them in the inspector, your method needs to be set to public or it won't show up. Also, your method can't have any parameters or return types. Back in the editor, I'll attach the script to the button and click on the small plus icon on the OnClick box. We get a new entry. Drag the attached script to the object field. Now the function drop-down will be activated. Navigate to the name of your script and a side menu will pop up. It's sorted by alphabet. I'll pick Do One Thing. When I now run the game and click on the button, the method gets called. If we repeat this process with a second method, in this case Do Another Thing, we can see how the order in which the methods are displayed in the box is the order in which methods are getting called too. You can switch the order by clicking and dragging the thin lines to the side of each entry. But what if you don't want to or simply can't set the methods in the inspector? To every event, and boxes like this OnClick event are just that, we can add so-called listeners. I remembered how this works by thinking of these events as a bat signal and listeners as Batman. On button click sends an event, the bat signal. There are things that listen to, or in this case rather watch for, this event to happen to spring into action. And hey, if you enjoyed this tutorial so far, please give it a like and consider subscribing for more UI-centered Unity tutorials. We can achieve assigning methods through code like this. Back in our script, we need a reference to the button. Make sure you added the correct namespace at the top of your script. In Start, we add a listener to the OnClick event like this. Name of our reference, .onClick.addListener, with the name of our method inside the brackets. This is called toSubscribe to an event. We also need to make sure to always unsubscribe everything we added too. I typically use the Unity method of onDestroy for this. It gets called when the element this script sits on gets destroyed. If we don't unsubscribe, our game will run into strange behaviors at some point. We can subscribe private methods through this, for example, but methods with return types or parameters are still off limits. In the inspector, you won't be able to see methods added to the buttons OnClick through this method, but we can have a mix of inspector set and code edit methods. And we can also change values of our button components through scripts. For example, to toggle a button interactable, I'll add the button I want to influence as a new reference at the top. We can use the name of that button reference, .interactable, and assign either true or false depending on our need. We can change the colors of our transitioning by color mode, like this for example. I assign a color I want to use when the player hovers above it. I start with a check for if the button's transition mode is, in fact, color tint like this. Then we grab the color block. That means all the color transitions assigned to the button. We can access each entry. In this case, I want to get the highlighted color and set it to our predefined color. And then we need to assign the block back to the button. We can see the changes happening in play mode. Sprites for the sprite swap can be influenced in almost the exact way. We just need to make sure to check if the transition mode is sprite swap, grab the whole block of sprites, this time it's called the sprite state, and assign the sprites we want. So, when it comes to bugs, you might run into the issue where you have buttons and they just refuse to acknowledge being interacted with. They won't react to hovering or clicks. In those cases, you'll need to check your hierarchy. Basically, whenever you click with your mouse, a ray is shot at the mouse's location onto your UI, and it will go through each layer it finds at that location and will get blocked if it finds something that blocks rays. Let's look at the hierarchy. First, the buttons are listed, then the frame. The ray meets this image first on its path, and since the image has a checked raycast target, it gets blocked. That way our buttons will never see any interactions because they are basically behind an invisible wall. By moving the image upwards in the hierarchy, we can see that the buttons are then not hidden behind the invisible wall of our frame anymore and can be interacted with again. And lastly, if you need more control about certain aspects of our buttons, like things that should only happen while on hover enter or while the player is scrolling on it, you might enjoy having a look at the event trigger component. It offers Unity events for a lot of typical UI use cases. So, that's it for buttons. I recommend watching my tutorial on canvas mode and anchors next, so you will be able to craft UIs that behave correctly on different screen resolutions. I hope you enjoyed the tutorial. Good luck with your game and have a great week.